Hello everyone, I'm Anjali Shukla. Welcome to our channel PeachyCloudSecurity. Today we'll discuss AWS EKS fundamentals. Let's get started. This is section 5 of our OWASP EKS Code project, Introduction to EKS and Key AWS EKS Component. So what is AWS EKS? It is fully managed service that simplified Kubernetes deployment, management, scaling on AWS. It means developers can deploy their application without worrying about the complexity of the underlying infrastructure. And it is AWS managed, so we can easily integrate it with other AWS services, and it will help in monitoring as well. What are the key benefits of AWS EKS? This is fully managed by AWS, highly available in nature, and we can easily scale up and scale down depending upon the traffic of our application. Let's discuss in detail what are the components we have in AWS EKS. So there are mainly two components. First is control plane and second is data plane. So whenever we have our Kubernetes managed by any cloud provider, control plane is the responsibility of that cloud provider. In this case as well, control plane is entirely managed by AWS. It has API server, etc., controller manager, and scheduler. API server is brain of your cluster and it manages communication, authentication, authorization. Next is etc., which is a key value database. It stores all the information of pod services deployment in a cluster in terms of key and value. Next is controller manager, which takes care that our cluster is running in a desired state. Means if 3 pods of an applications are running, then all the time 3 replicas will be maintained. Next is scheduler. It decides then on which particular node our pod will schedule depending on the resources like CPU, memory, etc. Next, we have a data plane. So data plane is the one where our workloads running. So EC2, which is a server in AWS, will be considered as a node for our workload. It also provides scaling and integration with other services like auto scaling group, load balancers. So we can integrate it with auto scaling group, and depending upon the traffic we are having on the application, our cluster will scale up and scale down. Each worker node is an EC2 instance in AWS EKS cluster. So let's say if we have a 10 node, means 10 EC2 instance will be present, and on each instance kubelet will be running to communicate with the API server. So from the control plane, API server makes all the communication, and from the data plane, kubelet makes all the communication to the API server. And on these nodes, our application pods will be running. In case you don't want to manage the data plane, then we have an option for serverless as well, which is Fargate. We can run our applications on Fargate, and our data plane will also be managed by the cloud provider. So it is cost efficient and it is using the serverless architecture. Networking is very important in EKS, and each pod gets its own IP address to communicate with other pods. And in case you want to expose your application externally, then you can just create a load balancer and it will be created automatically. For example, you can set up an application load balancers to route the traffic between your pod on a specific path. Next, we have a security with IAM. In Kubernetes, we talk about two kind of an IAMs. First is IAM for pod, which is IAM role for service account, and second is RBAC, role-based access control. For example, my pod wants to access the S3 bucket. So I will create an IAM role, attach the required permission to access an S3 bucket. This IAM role I will attach to Kubernetes service account. That service account I will attach to a pod, and my pod will be able to access the S3 buckets. Now, what is the difference between IRSA and RBAC? IAM role for service account helps you to assign IAM permissions to the pod, and which further grants access to other AWS services. Whereas role-based access control grants you access to perform a specific actions, like you can list all the pods, services, like what all action you're doing within the cluster is managed by your RBAC. In case EKS or a pod wants to connect with other AWS services, then we'll take a help of IRSA. Next, we have a storage. So we have a ephemeral storage, EBS and EFS. Ephemeral means temporary storage. If the pod goes down, your data will be gone. Whereas if you want persistent storage, you can take help of Amazon EBS, which is Elastic Block Storage, and it is good for stateful applications like database. In case you want your pods or applications to share the data, then you can use a Elastic File System. It is good for sharing the data. Last, we have monitoring and observability. We have AWS CloudWatch for monitoring all the matrices like CPU usage, memory, network, everything. Then we have a GuardDuty, which is a runtime security tool. You can detect all the suspicious activities, unauthorized access using Amazon GuardDuty. This was it in this video where we briefly discussed about the data plane, control plane, storage, monitoring, observability, how the IAM works in AWS EKS. In the next video, we will start a hands-on lab starting with the deployment of our vulnerable environment. So stay tuned and thanks for watching.